Hey guys, welcome again to my vlog. So for today, we discuss the summary of the chapter 7. Networking Academy. The chapter 7 is the IP addressing. So what is IP addressing? Binary is a numbering system that consists of the numbers 0 and 1 called bits. In contrast, the decimal numbering system consists of 10 digits consisting of the numbers 0 to 9. Each address consists of a string of 32 bits divided into the 4 sections called octets. Position notation. Positional notation means that a digit represents different values depending on the position the digit occupies in the sequence of number. So, this is the example of the positional notation. This is the digit, the thousand, hundreds, tens, and ones. Binary to decimal conversion. To convert a binary IPv4 address to the dotted decimal equivalent, divided the IPv4 address into the 4 8-bit octets. Next, apply the binary positional value to the first octet binary number and calculate accordingly. Decimal to binary conversion. Write down the decimal number. Divide the number by 2. Write the result underneath. Write the remainder on the right hand side will be 0 or 1. Divide the result of the division by 2 and again, write down the remainder. Continue dividing and writing down remainders until the result of the division is 0. The most significant bit or MSB is at the bottom of the column of remainder, and the least significant bit or LSB is at the top. Read the series of the ones and the zeros on the right from the bottom up. This is the binary equivalent of the divided decimal number. Network and host portion. The bits within the network portion of the address must be identical for all devices that reside in the same network. The bits within the host portion of the address must be unique to identify a specific host within a network. If two hosts have the same bit pattern in the specific network portion of the 32-bit stream, those two hosts will reside in the same network. The subnet mask, IPv4 address, subnet mask, and the default gateway. The first is IPv4, unique IPv4 address to the host. Next is the subnet mask, used to identify the network host portion of the IPv4 address. Default gateway identifies the local gateway or the remote reach network. Logical end. A logical end is the one of the three basic binary operations used in digital logic. The other two are OR and the NOT. While all three are used on the data networks, only end is used that determining the network address. This is the binary, the subnet mask, and the end result. The prefix length. What is the prefix length? The prefix length is the number of bits set to 1 in the subnet mask is written in the slash notation, which is followed by the numbers of bits set to 1. Therefore, count the numbers of bits in the subnet mask and prepend it with slash. So this is the example of the subnet mask, 32-bit, and the prefix length. As you can see in the diagram. Static IPv4 address assignment to a host. A host can also be configured with a static IPv4 address such as shown in the figure. Assigning host static IP addresses is acceptable in small network. However, it will be time consuming to enter static addresses on each host. In a large network, it is important to maintain an accurate list of static IP address assigned to each device. Dynamic IPv4 address assignment to a host. As shown in the figure, A host can obtain IPv4 address information automatically. The host is a DCHCP client and requests IPv4 address information from DHCP server. The DHCP server provides an IPv4 address, subnet mask, default gateway, and other configuration information. IPv4 communication. A host successfully connected to a network can communicate with other devices in one of three ways: the unicast, the broadcast, and the multicast. Unicast is the process of sending a packet from the one host to an individual host. Second is the broadcast. Broadcast is the process of sending a packet from one host to all hosts in the network. Multicast, the process of sending a packet from one host to a selected group of hosts, possibly in different network. Public and private IPv4 addresses. Public IPv4 addresses are addresses which are globally routed between the ISP or Internet Service Provider routers. However, not all available IPv4 addresses can be used on the Internet. There are blocks of addresses called private addresses that are used by most organizations to assign IPv4 addresses to internal hosts. Special user IPv4 addresses. There are certain addresses such as the network address and broadcast address that cannot be assigned to hosts. There are also specific special addresses that can be assigned to the host, but with restriction on how those hosts can interact within the network. The loopback addresses, linked local addresses, and the testnet addresses. So this is the example. Classless addressing. The system in use today is referred to as classless addressing. The formal name is Classless Interdomain Routing or CIDR pronounced CIDR. In 1993, the IETF created a new set of standards that allow service provider to allocate IPv4 addresses on any address bits boundary or prefix length instead of the only by class A, B, or C address. This was to help delay the depletion and eventual exhausting of the IPv4 addresses. IPv4 and IPv6 coexistence. The migration techniques can be divided into three categories: dual stack, tunneling, and translation. Dual stack, it allows the IPv4 and IPv6 to coexist on the same network segment. Dual stack devices run both IPv4 and IPv6 protocols stack simultaneously. Tunneling. Tunneling is a method of transporting an IPv6 packet over an IPv4 network. The IPv6 packet is encapsulated inside the IPv4 packet, similar to other types of data. Translation. Network address translation 64 or NAT64 allows IPv6 enabled devices to communicate with IPv4 enabled device using a translation technique similar to NAT for IPv4. An IPv6 packet is translated to an IPv4 packet and vice versa. IPv6 prefix length. IPv6 uses the prefix length to represent the prefix portion of the address. IPv6 does not use the data decimal subnet mask notation. The prefix length is used to indicate the network portion of an IPv6 address using the IPv6 address or the prefix length. So, IPv6 unicast addresses. The most common types of IPv6 unicast addresses are global unicast addresses. The first is global unicast. A global unicast address is similar to a public IPv4 address. These are globally unique internet routable addresses. Global unicast addresses can be configured statically or assigned dynamically. Link local. Link local addresses are used to communicate with other devices on the same local link. With IPv6, the term link refers to a subnet. Link local addresses are confined to a signal or single link. So, unique local. Another type of unicast address is the unique local unique address. IPv6 unique local addresses have some similarity to RFC 1918 private addresses for IPv4. but there are significant differences. IPv6 address type. There are three types of IPv6 addresses, the unicast and the multicast and the anycast. So this is the meaning of the unicast, the multicast and the anycast. ICMP v4 and ICMP v6. Host configuration. An ICMP echo message can be used to determine if a host is operational. The local host sends a ICMP echo request to a host destination or service unreachable. When a host or gateway receives a packet that is not cannot deliver, it can use an ICMP destination at unreachable message to notify the source that the destination or service is unreachable. Time exceeded. An ICMP PB4 time exceeded message is used by a router to indicate that a packet cannot be forwarded because the time to leave field of the packet was decremented to 0. This is the ping testing the local stack. Ping is a testing utility that uses ICMP echo request and echo reply message to test connectivity between hosts. Ping works with both IPv4 and IPv6 hosts. Ping testing connectivity to the local LAN. So this is the ping testing connectivity. Ping testing connectivity to remote and trace route testing to the path. That is the meaning of that two topic. So that's all for chapter 7. I hope you learned something from my blog. So thank you and goodbye.